It's taken us a while to get here, but it's finally time to put the whole rig together. Let's start by naming the armature, which we haven't done yet. Name it Rig, like always. And let's also get things rolling by adding a root bone. That way we can parent things to it as we go along. Remember to position and align it so that it matches with the world axes. And, of course, name it root. And right away, let's parent the bottom body bone to the root bone. The thing that makes a root bone work is that everything in the rig is either directly or indirectly its child. That way everything ultimately exists inside its space and moves with it. So as we go along rigging, we need to make sure that anything that isn't already the child of something else is the child of the root bone. You can verify that the root bone is working properly at any time by just selecting it in pose mode and moving it around. If everything moves with it properly, you're golden. But if not, that means you missed a parent-child relationship somewhere. Either that, or you were silly enough to think that turning off inherit rotation was a good idea. These options can be nice shortcuts in a quick throwaway rig, but you should avoid them in full character rigs. They make setting up a proper root bone nearly impossible. And besides, there are other ways to accomplish the same effects. For example, the socket rig we first made for the FK arm does exactly the same thing as toggling inherit rotation off, except it doesn't interfere with creating a root bone. Now let's add the controls for the body. It's just 2 additional bones. I'll make them by duplicating the top and bottom bones. And make sure to parent them to the root bone, since they're not going to have any other parents. And let's name them. And let's add the copy transform constraints. In this case, there's only one middle bone, so adjusting the influence of its constraints is pretty simple. And now resize and position the controls appropriately. And constrain the top body control to the location of the bottom body control. Let's test and make sure everything is working so far. Awesome. Now let's do the arms. Remember that we need to make the FK controls and IK controls separately, and then we have the bones that actually control the mesh switch between them. So let's make 2 duplicates of the arm and hand bones, one for the FK controls and one for the IK controls. Offset them vertically above and below the bones that deform the arm. We'll move them back when we're done. Now let's name everything. We'll make the top bones the FK arm and the bottom bones the IK arm. We're just going to use FK and IK to distinguish the 2 arms. And remember that the IK arm bones are never directly touched by the animator, so they're mechanism bones. And now let's set up the FK rig. Create a socket bone and a parent bone for the arm. Now name the bones. Remember, these are both mechanism bones. And don't forget to do both sides of the rig. And make the arm the child of the parent bone. Now add the copy location constraints. Now if we rotate the upper body control, we can see our FK controls not following the rotation, just as we expected. But what about rotating the root bone? Oops! The arms don't follow the root either, which is not what we want. Everything should follow the root. The reason this happened is because we forgot to make the arm parent the child of the root bone. So let's fix that. Make the arm parent the child of the root bone. Now the arms follow the root bone. Woohoo! But they still behave properly when rotating the body. Awesome. Now let's add the copy transform constraints, which will allow us to make this a toggleable behavior. Now if we rotate the upper body bone, aha! It follows! Wonderful. Now we need to set up the custom property to control this switch. Unfortunately, there isn't an obvious best choice for where to put the custom property. It's partly a matter of taste and partly a matter of use case. But for Mr. Hot Dog, we're just going to put it on the upper arm. We're going to call it isolate rotation. And make sure it has a min and max value of 0 and 1. Now let's copy its RNA path, and add and set up the driver on the copy transforms constraint. Let's test this out now. Rotate the upper body control, and slide isolate rotation on and off. Well, it seems to work well, except that the slider seems to do the opposite of what it says. When it's turned all the way off, the arm's rotation is isolated from the body, and when it's all the way on, the arm's rotation follows the body. That's not what the name of the slider indicates. That's the opposite. You would expect the arm to be isolated when the slider is on. This is where I get to introduce a new aspect of drivers. You see, it's no coincidence that you configure the drivers in the fcurves editor. Now, we could just adjust this driver by using scripted expressions and entering 1.0 minus var, and that would flip the behavior of the slider just fine. But that would be no fun. Then I'd have no excuse to expose you to the third part of drivers. Remember, in the drivers panel, there are two parts, the variables and what is done with those variables. Well, there is also a third part, which is the fcurves editor. The value produced by the what is done with variables part is further processed by an fcurve. If there is no fcurve associated with the driver, it will just use the value directly, but if there is an fcurve, it will find the horizontal position that corresponds with the value, and then use the vertical value there as the result. So, for example, if the value out of here is 0.5, then the driver finds 0.5 on the horizontal axis, and finds the vertical position of the fcurve at that point, and uses that value as the final driven value. So you've probably noticed two things by now. First, there's already an fcurve here, and secondly, we ended up at 0.5 again. The reason there's already an fcurve is because Blender automatically adds an fcurve generator to drivers, and that generator maps every number to itself. This generator is one of many so-called fcurve modifiers, and they are quite powerful tools. They allow you to procedurally generate and alter fcurves, and they do so in the same stack-based way that constraints and modifiers do for matrices and geometry. I definitely recommend playing around with these fcurve modifiers. In fact, we could accomplish what we want by tweaking the values of just this generator here. However, I think it will be easier for us to simply create an fcurve manually. And to do that, we need to delete the generator. So click X to remove it. To reverse the effects of our slider, we want to map 1 to 0 and 0 to 1, right? Whenever the slider is at 1, we want the constraint influence to be 0, and vice versa. So for the first point on our f-curve, let's find the horizontal 0, and place a point at vertical 1. This will map 0 to 1. To add the point, hold down Control and left-click. For the second point, we want to find horizontal 1, and place a point at vertical 0. This will map 1 to 0. If we test this out now, yay, it works! However, we're not quite done yet. Right now, our f-curve is curved. Also, since we placed the points by hand, they are almost certainly not at exactly the values we want. To address the first problem, we simply select all the points, hit T, and select linear. Now the f-curve forms a nice straight line. To make sure the values are exactly how we want, we can select one of them and go to the Active Keyframe panel. Here we have direct access to the selected point's coordinates. And as we suspected, they are not exactly what we wanted. So let's enter the values we did want. And let's do the same for the other points. Awesome! Now our driver is perfect! This ability to create f-curves to alter drivers' behavior is extremely powerful. It's kind of overkill for this situation actually, but there are many cases where it can be invaluable to create complex driver curves. Finally, let's set up the rotation mode and axis locks for the bones. I'll do all of this same stuff to the arm on the other side now, but off-screen. It's exactly the same process, just keep in mind that we want separate control of the rotation isolation for each arm, so make sure to create and use a custom property on the other arm as well. Now it's time to build the IK arm rig. The process for this is identical to the process for Mr. Squeegee Feet's leg rig, so go back and watch that for detailed instructions. I'll just breeze through it here, only highlighting things you should take special notice of. Before we do anything else, we want to unparent the IK hand, since it's going to be IK target. However, we do want the IK hand to move with the root bone, just like everything else, so make it the child of the root bone. And now let's create the pull target, naming and positioning it appropriately. We'll want this to be the child of the uppermost body bone. Not the control for the upper body, but the actual bone. That way, the pull target will follow the body in an appropriate way. And since this arm is perfectly straight, we'll want to do IK hinting on the elbow so that it doesn't freak out. Bend the arm slightly and add drivers to its rotation channels. Now let's do all the IK setup, just like on the leg rig. Ta-da! That's it for the IK. Now I'm going to do the same thing for the arm on the other side. I'll be back in a jiffy. Now we just need to constrain the intermediate arm bones to the FK and IK arms. First, add the constraints for the FK. Then the IK. And name the constraints. And now we need to make a custom property that will drive the IK-FK switching. This is another case of there not really being an obvious best place for it to be. For Mr. Hot Dog, we're going to put it on the IK hand control. We're going to name this FK_IK. The order here is important, because I want the FK to indicate the side of the slider that means FK, and IK to indicate the side of the slider that means IK. In this case, left is FK, and right is IK. And make sure it has a min and max of 0 and 1. Now let's move the IK hand so that we'll be able to tell when our switch is working. And copy the RNA path of the custom property so we can paste it later on. Select the upper arm on the intermediate chain, and add a driver to the second constraint's influence. Now configure the driver to use the custom property. And let's try it out. Yay, it works! Now we just have to copy the driver to the forearm and hand constraints. Now when we use the slider, woohoo! Awesome! Finally, let's move all the arm bones that the animator won't be using to a hidden layer. And let's move the FK and IK controls to separate layers, and put the arm bones back into the same overlapping position in edit mode. Now we can seamlessly use both the IK and FK controls. And of course, let's make sure that it's all working with the root bone. Yep. Now, as always, I'm going to go and do this for the other arm off screen. All we have left now is the fingers and the eyes. We're so close. Let's do the fingers next. The first thing we're going to want to do is set all of the rotation modes to the appropriate Euler rotation order. We're going to use the same rotation order as in the finger video, Y, Z, X. Let's do this on both sides of the character. If you recall, we'll be doing the finger rigs with action constraints. One of the cool things about action constraints is that you can use the same action from multiple action constraints. Therefore, we really only need to make a single action that has every finger in the rig bending, and we can use it for all of the finger rigs. So let's do that. Go ahead and key all of the unbent fingers on frame 1. Then switch to frame 11 and bend all of them. And key all of them in the bent position. Now scrub the timeline to make sure we did it right. Excellent. Now let's go to the action editor. Remember that it's part of the dope sheet. Let's name the action finger bend, and set all of its keys to linear interpolation. And finally, let's remove the action from the armature. The fingers are still bent. What happened? What happened is that we removed the action when we were on a frame with the fingers bent. And when you remove an action, the current pose still remains. It's just not animated anymore. To fix this, simply select all the fingers and clear rotation. Now let's create one of the finger rigs. I'll just do one, and then I'll do the rest off screen. It's the exact same process for all of them. First, we need to create the control bone. It's important that the control have the same parent as the finger. After all, if the hand moves, you kinda want the finger controls to go with it. In this case, since I duplicated the finger's first bone to create the control, I know that they both have the same parent. Now scale the control out to be a bit longer than the finger, and name it. Add the action constraint to the finger bone, and configure it. And let's test it. It works! Yay! Now copy the constraint to the tip of the finger. And constrain the rotation of the base of the finger to the control. And let's test this. Yay, it works! However, there is one little thing that I didn't mention in the finger tutorial, because it's easier to demonstrate on a full rig like this. Try scaling the root bone down, and watch the finger while you do it. You'll notice that the finger is bending. That's because right now, the action constraint is triggered based on the world space scale of the finger control bone. When any of its parents scale down, it scales down too, and therefore the finger bends. But that's not what we want. Fortunately, we can just change the action constraints to use local space. Now when we scale the root bone down, the finger stays put, because now the constraint only cares about the local scaling of the control. In most cases, this probably isn't actually that critical, but especially for a cartoony rig, the animator might want to scale the character's hand for some reason, and we don't want the fingers suddenly bending when they do that. Now we just need to move the control back into place. And lock the transforms of the control. And we're done. Now if you'll allow me to rig the rest of the fingers, I'll be back in a jiffy. We're almost done with the actual rigging. We just need to do the eyes now, and then a few polish items. For starters with the eyes, let's just set this up the same way we did for Mr. Squeegee Feet. And now let's set up the switchable parent for the eye target and the head. Make sure to use the uppermost body bone for that, not either of the body controls. And the real parent should be the child of the root bone. Now make the animation for the eye crossing. Set up the action. And add the action constraint and configure it. The local space thing applies here too. And copy the constraint to the other eye bone. And of course, lock the Y and Z scaling axes of the eye targets. And we're done. Except for a couple of things. Obviously, we need to sort things into the appropriate layers and add some shapes for the controls. So first, anything that's not a control should go to a hidden layer. As for sorting controls onto separate layers, we've already done that for the arms, and I think the only other controls we should put on another layer are the individual eye and finger digit controls, since they're really not going to be used most of the time. Now it's time to create some control shapes. In the previous videos, I've mostly just had the shapes pre-made, but I want to show you a bit of that process now. It's pretty simple. The hard part is figuring out what the best, most clear to the user shapes are. And if I'm being honest, I have to say, I don't think I really have the best solutions for that yet. In any case, for the body, we only have two controls. I think they would probably be best as circles around the top and bottom of his body. I also think that the control for the top, despite the fact that the actual control is at the bottom, should pretend to look like it is at the top. The process for creating these shapes is just to make a mesh for each. In this case, I'm going to start with circles. And let's name them WGT and the name of the controls. And right away, let's assign them to be the shapes of the controls. And for the top control, we're also going to set the at field to body.03 so that it appears on the top of the body. Now, obviously, this is not how we want the shapes to look. The first trick is to orient the meshes to be consistent with the bones. To do that, turn on axis display on the meshes. If we select the bones, we can now see how we need to rotate the meshes to line up their axes with those of the controls. So let's do that. We can now also move and scale them to be in approximately the same place as the controls. It doesn't have to be absolutely perfect, just close enough for your personal comfort when we edit them. So now on each of these meshes, we can go into edit mode and modify the mesh to be how we want it to appear on the rig. Now move the meshes to the last scene layer to hide them. And now we have custom shapes on our controls. I use the same process to create all of my control shapes. However, keep in mind that with a lot of controls, like for example the finger controls, you can often get away with just making one shape and using it on all of them. So keep that in mind. So now I'm going to go off screen again and create the rest of the shapes. I'll be back in a flash. There are two final things to do. The first, of course, is to turn off the armature's X-ray and axis display and the character's mesh wireframe, etc., etc. So let's do all of that. But the second is something new. We have a few bones like the bottom body bone and the IK hand bones that need to be aligned a certain way for rotation, but which are also used for translation. What this means, for example, is that the body bone's y-axis is pointing up, but the IK hand's y-axes are pointing to the right and left, respectively. So their translation axes are inconsistent with each other, and they're also inconsistent with the root bone and the world space coordinates. That's not really a good thing, but how in God's green earth can we change that? If we reorient these controls for good translation axes, then the rotation axes will be all screwed up. But if we don't, then their translation axes will stay screwed up. Thankfully, Blender comes to the rescue again. If we select any of these controls and go to their bone properties, under the Relations panel, there's an option named Local Location. If we toggle this option off, then the translation axes of the bone will no longer be aligned with its local axes. Instead, it will use its parent's space to determine the orientation of these axes. For controls that are floating out in space and are just the children of the root bone, that means their translation axes will be properly aligned. Yay! So for all of these free-floating controls, let's toggle that option off. Now all of these controls' translation axes are consistent with each other. But the rotation axes are untouched. They are exactly the same as they were before. Nifty, eh? If you ever run into a situation where you need a bone's translation axes well aligned, but its parent is not well aligned, you can simply insert a hidden parent between the two of them and orient that parent the way you want the translation axes to be. Although keep in mind that if the parent rotates, it's going to change the axes anyway, since they exist inside its space. Anyway, that's it. We now have a complete Mr. Hot Dog rig. Congratulations!